This tutorial is the second part of a two-part tutorial explaining mat foundation design using STAAD Foundation Advanced software. It will cover everything after the mat job has been analyzed, including moment envelope generation and reinforcement zoning. I will start exactly from where we left off in the last video, which is analyzing the mat job. Most of the tools seen in this video are under mat slab analysis or design options. Once the analysis is complete, various results can be visually shown through output view options. For example, select Global MZ under Select Stress Type and check Plot Contour on Deflected Shape to view stresses caused by moment in the Z direction. For further viewing options, go to Scale Setup Options under Project Info to change the viewing scale of displacements, loading scales, and modeling scales. I will decrease displacement to 0.01. You can see the change in the geometry view. Also, under Modeling View options, I will turn off Show Supports, Show Plates, and Show Boundary and Holes to hide these objects. Now, just the stress on the deflected shape is shown. The stresses for each load case can be toggled in the Home ribbon. If the load is not a part of the job, then the stresses won't be shown. Similarly, the user can view the soil pressure in Output View options. As analysis results are in the local plate direction, we need to convert them into the reinforcement direction for reinforcement design. The user can choose longitudinal direction of the reinforcement for each mat boundary through moment envelope generation. The user can set longitudinal direction parallel to the X or Z direction, enter coordinates for the longitudinal direction, or draw the reinforcement direction graphically using the By Drawing a Line on Slab option. I will use the Along Global X-axis option. Once reinforcement direction has been set, the user needs to specify design division points. Keeping them at default works in most conditions, but for large mats, the user may want to increase the division number. Also, the user needs to select load types. If ultimate loads are not defined, choose Use All Load Cases. Once moment envelope is generated, Geometry View will show the mat boundary with multiple points generated on it. The orientation of the design points is based on the longitudinal reinforcement direction we specified earlier. Now the program has converted local plate forces to forces in the direction specified earlier. These are the discrete points to be used to design the slab. In other words, these points will be designed independently and then will be merged to calculate reinforcing patterns or contours. Once the moment envelope is generated, go to Design Parameters and specify the design parameters. Then hit the Design button. After design, Result Summary will show governing load cases and locations for top and bottom face design in both directions. Details Report gives design moments and area of steel required at all design points created through moment envelope generation method. Detailed Report also has a punching shear tab. A punching shear check is performed automatically if reaction loads are specified on top of the mat. For reinforcement zoning, first choose the face of the slab and create zones for all four faces. As you can see, these zones might not be practical to distribute reinforcement. The user can rearrange zones using the Zone Editing tool. First click on Select Nodes and then select the area of interest on the mat. Then click on Reset Zone. The governing reinforcement in the selected area is assigned to that whole area. The user must create zones at all faces to see reinforcement calculations in the calculation sheet. There is another method the user can choose to design the slab. The user can draw a line on the mat graphically or enter the coordinates to insert a design line on the mat. This method uses unit tributary width for the cut line and design for the forces along it. You can check one-way shear by cutting a line on the slab manually. The important option is to check slab capacity. The user can check the mat for a particular reinforcement layout. For example, for number 6 reinforcement at 12-inch spacing, the user can check which area of the mat is failing. The area in red shown is failing for design forces with the specified reinforcement. Click on the Calculation Sheet button to generate the calculation sheet. This process is unlike the other Foundation modules where the calculation sheet is generated automatically after design. I would like to reiterate that the user must create zones at all faces to see the reinforcement calculation in the calculation sheet. The other design tool is to check the bending moment diagram for any beam assigned to the mat. To check the moment and shear diagram, simply double-click on the beam and it will bring up the dialog box to show graphs with minimum and maximum values. These values can be directly used to design beams. This version also provides a GA drawing for mat, so overlap between other foundations can be detected. Thank you for watching this tutorial.